we have seen that we talked about the oxidation and reduction of this alcohol. Primary alcohol oxidizes into aldehyde and secondary alcohol oxidizes into ketone, and tertiary cannot be oxidized. And if you are going to give a very drastic condition, then the carbon-carbon bond will be broken and it will be oxidized into carboxylic acid. And only the condition if you are going to use a very strong oxidizing agent. Now, there are other methods to oxidizing, like if you have primary alcohol RCH2OH and you are going to, this alcohol should be in vapor and you are going to pass it through copper at 573 Kelvin, then the product, since it is a primary, then it will be converted into aldehyde. And if you are going to use this secondary alcohol, then it will be converted into same condition, it will be converted into ketone RC-double-bond-O. Now the next point, if you are going to oxidize tertiary like this, you can see this is a tertiary alcohol, and the condition is now again similar. These alcohols are in vapor phase. Copper at 573 Kelvin. Then here also elimination competes over substitution. Sorry, not elimination competes over substitution. Then there will be the formation of alkene CH3 C double bond CH2. So basically elimination took place here. Elimination took place. Dehydration took place. That's why alkene formed. So I'm going to write a point about this. When vapors of primary or secondary alcohol are passed over heated copper at 573 Kelvin. Then dehydrogenation takes place. Dehydrogenation takes place. And an aldehyde and ketone formed respectively. While tertiary alcohol undergo dehydration. That's why alkene formed. So please do write it and let me know when you are done with this. Fawaz, you just joined.
Yes, sir.
Yes, sir, finish.
Let me know when you are done with this, Fawaz.
Sir, 1 minute. Done, sir.
Very good. Now we are going to study the reaction of phenols. Reaction of phenols. This is very easy. So see how we are gonna see the reaction of phenols. There will be electrophilic substitution, aromatic substitution. Since we are talking about phenols, so it will be aromatic substitution. Reaction of phenols, electrophilic aromatic substitution, in which we have to study about nitration. And what does it mean? You know that nitration is basically addition of nitro group in phenol. So how we are gonna add it? This is phenol, and the reaction type is electrophilic aromatic substitution reaction. In order to add a nitro group in this, we need to react this with dilute HNO3, dilute HNO3. Then NO2 will be added at two positions. NO2 will be added at two positions. First is ortho, and the second is para. And the second is para. So first of all, you are going to write it. Please wait a minute. I will. Are you done with this? The fish and pause.
Yes, yes, sir.
Now see, have you written the name of this? This is basically O, that means orthonitrophenol. Orthonitrophenol, and this is P-nitrophenol. P-nitrophenol. Now we are going to talk about steam volatile, which one is more volatile and which one is less volatile. The compound which is more stable is less volatile, and the compound which is less stable is more volatile. So I'm going to write a point and then explain it. So you can write with me. The ortho and para isomers, we can call it para isomers. That means same molecular formula, different structural formula, can be separated. They can be separated by steam distillation. Steam distillation. Steam distillation. Actually, the ortho nitrophenol, O-nitrophenol, is steam volatile. Steam volatile. Why it is steam volatile and para is not steam volatile? Because due to intramolecular hydrogen bond. Do you know what is intramolecular hydrogen bonding, Nafisa? Why? Para-nitrophenol is less volatile due to intermolecular hydrogen bond. Intermolecular hydrogen bond, which causes association, which causes association of molecules. Pause and Nafisa, let me know, do you know about intermolecular hydrogen bonding or intramolecular hydrogen bonding? Fawaz, am I audible?
Yes, sir.
Do you know what is intermolecular hydrogen bonding?
No, sir. No, sir.
Okay. So see, basically, intra that means in the molecule. Intra that means in same molecule. Or inter that means basically two different molecules or two molecules, between two molecules, between two molecules. I'll show you. It's very easy to understand. Please be focused here. So this is your, I'm going to draw, this is your orthonitrophenol. This is your orthonitrophenol. I'm going to draw it. Please be focused here. So this is O, this is nitrophenol. So there will be a hydrogen bonding between oxygen and hydrogen. And you can see that this is inside the molecule. In a molecule, if there will be hydrogen bonding, that is known as intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Now, what is intermolecular hydrogen bonding? It's very easy to understand. You can see if you have paranitrophenol, please be focused here. If you have paranitrophenol, you can see that there will be no hydrogen bonding in this single molecule. But if you have another molecule, since a lot of molecule, millions of molecule of paranitrophenol will be there, so there will be intermolecular hydrogen bonding. That means basically you can see that these two molecules will have hydrogen bonding, that is called intermolecular hydrogen bonding. Intermolecular hydrogen bonding. And it is more stable, that's why it is less volatile, and it is less stable, that's why it is more volatile. Yes, you can see why I am saying this is more stable, because two molecules combine to form a single molecule, which increases its atomic molecular mass, and molecular mass is directly proportional to van der Waals force of attraction. So basically bond becomes stronger than this, that's why it is less volatile than this. Please do write it and let me know when you are done with this. It's very easy. Alia, why are you late? Please do let me know when you are done with this.
Yes, sir. Finish.
Very good. Fawaz and Alia.
Sir, 1 minute.
Okay. Fawaz, are you done with this? Very good, Alia.
Yes, sir. Then.
Okay. Now see, it's very easy to understand. There is another reaction of this phenol, but the condition changes. The reactant, other reagent changes. This is a phenol, and in the previous reaction of this, we use dilute HNO3. But if you are going to use concentrated HNO3, then we will get picric acid. That means picric acid is basically, this is OH. With respect to OH, we will get NO2 at ortho, another NO2 at para, and another NO2 at ortho again with respect to OH. So this its common its IUPAC name will be basically 2,4,6 trinitrophenol, and its common name, which is very famous, is picric acid. Picric acid. Are you done with the reaction? Fawaz, are you done with the reaction?
Yes, sir.
Another method to prepare picric acid is basically you are going to react phenol with concentrated sulfuric acid, which will convert phenol into phenol 2,4 disulfonic acid, and disulfonic acid will be treated with concentrated nitric acid, which will convert it into picric acid. Can you write the reaction? Nafisa, Alia, please write it and let me know. Can you write the reaction or not?
Sir, what did you write before disulfonic?
Picric acid is also prepared by treating phenol first with concentrated sulfuric acid, which converts it to phenol 2,4 disulfonic acid, then with concentrated nitric acid to get picric acid. Got it, Nafisa?
Yes, sir. Okay.
Please do write. Can you write the reaction, Nafisa?
Yes, sir. I'm writing.
Very good.
Yes, sir. Finish.
Very good. Fawaz, so it's very easy. You can see if you are going to treat this phenol with concentrated H2SO4, you will get 2,4 SO3H, and this is also SO3H disulfonic acid. Again, if you are going to treat this with concentrated HNO3, then you will get, with respect to OH, there will be NO2, there will be NO2, there will be NO2. This is our picric acid. Is that clear, Fawaz?
Yes, sir.
Please write it. Let me know when you are done with this.
Yes, sir. Finish.
Very good. Fawaz, let me know so that I can change the slide.
Done, sir.
Very good. What about you, Alia? Now come to the next chemical reaction. That is basically bromination, or you can say halogenation. With the term, we are aware that halogenation, that means addition of halogen. And here you can see how we are going to add halogen in phenol. So it's very easy. If you have phenol, and you are going to treat this phenol or react this phenol with Br2 in carbon disulfide CS2 in cold, or you can say 273 Kelvin, 0 degree centigrade. Then bromine will be added at two positions. The first position is basically ortho, and the second position is para. And you know which one is minor and which one is major. So basically, this is your major compound, and this is your minor. Please do write. Another reaction of this is very important. If you are going to react this phenol with bromine water, which is reacting with 3Br2, then we will get 2,4,6 tribromophenol. With respect to which we will get Br at ortho, Br at ortho, and Br at along with a byproduct of 3HBr, and its name is 2,4,6 tribromophenol. Can you tell me the IUPAC name of this and this? Fawaz, Alia, and Nafisa.
Orthobromophenol and parabromophenol.
Yes. In numbering, instead of using orthopara, it's one, two bromophenol, and this is four bromophenol, right?
Yes, sir. Yes, sir. Finish.
Are you done with this, Fawaz?
Sir, 1 second.
Okay.
Done, sir.
Very good. Now come to the next chemical reaction, and it is also known as name reaction. That is basically coal-based electrolysis, coal-based reaction. We say coal-based reaction. Now first I'm going to write, and then I will show you the reaction and explain the reaction. So see what happens when phenol react with sodium hydroxide. When phenol react with sodium hydroxide, then phenoxide ion is formed. Then phenoxide ion is formed, which is more reactive, than phenol towards electrophilic substitution reaction. Towards electrophilic substitution reaction. Towards electrophilic substitution reaction. Now the question is that, not the question, sorry. When phenol is treated with or reacted with sodium hydroxide, then a phenoxide ion is formed, which is more reactive than phenol towards electrophilic substitution reaction, and then it is treated with it is treated with carbon dioxide, CO2. And CO2 is basically a weak electrophile. A weak electrophile. Treated with CO2 and ortho-hydroxy benzoic acid is formed. Ortho-hydroxy acid is formed as main product. So it's very simple to write the reaction after reading this complete sentence about coal base, that we have a phenol and phenol is going to be treated with sodium hydroxide. So you are going to write NaOH here, and then we get a phenoxide ion. We get a phenoxide ion which is more reactive towards electrophilic substitution reaction. And please write here electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. And this will be treated with CO2 in the presence of acid. CO2 in the presence of acid. Then we will get ortho-hydroxybenzoic acid. This will be COOH, and this will be, this is ortho-hydroxybenzoic acid, and its common name is basically salicylic acid, which is very important. Please write.
Yes, sir. Finish.
Very good. Pause.
सर थोड़ा आराम से.
Okay, take your time, no problem at all.
Done, sir.
Everyone done with this?
Yes, sir.
Very good. Now see, the next reaction is also very important. One of the most important name reaction of this chapter. That is basically Rimmer-Tiemann reaction. That is Rimmer-Tiemann reaction. Now see, what is this Rimmer-Tiemann reaction? Since we are studying electrophilic aromatic substitution reaction, basically reaction of phenol. We are studying a reaction of phenol. So here it goes. Phenol react with chloroform in the presence of sodium hydroxide and salicyldehyde is formed. Salicyldehyde is formed. And this reaction is known as RXN stand for reaction, is known as Remer-Tiemann reaction. Remer-Tiemann reaction. One important point is that an intermediate, during this reaction, an intermediate is formed. I'm going to write an intermediate is formed during this reaction. Which is hydrolyzed in the presence of alkali to produce salicylic to produce salicylic. So first you are going to write it, and then I will be writing the reaction. Let me know when you are done with this.
Done, sir.
Very good. Now see, the reaction is very easy. If you know what is phenol and you know what is the structure of phenol. So you are going to write phenol and treating this phenol with chloroform, which has a formula CHCl3 in the presence of aqueous NaOH, sodium hydroxide, as stated above. Then we will get an intermediate first. Then we will get an intermediate first, in which this will be the intermediate. This is intermediate. And this intermediate is then treated with NaOH. Then we will get this CHO introducing at ortho, and there is basically O minus Na plus, and after this we are going to pass it through acid, and then we will get salicyldehyde. This is your salicyldehyde. Salicyldehyde. Is right.
Yes, sir, finished.
Are you done with this? Fawaz?
Sir, 1 minute.
Okay, take your time.
Done, sir.
Very good. Now the next reaction we are going to talk about is basically reaction of phenol with zinc dust. With zinc dust. So basically, phenol, this is an important reaction too. Phenol is converted to benzene. Phenol is converted to benzene on heating with zinc dust or zinc, you can write. It's very easy. If you have this phenol and you are going to react this with zinc, then oxygen in phenol will be gained by this zinc and it will be ZnO. And it just converted phenol into zinc.
Yes, sir, finished.
Everyone, are you done with this?
Yes, sir.
Okay. Now, the next and the last chemical reaction of phenol is this oxidation. And basically what happens, basically oxidation of, we are doing oxidation of phenol with chromic acid produces a conjugated diketone. You will get it what it is. Conjugated diketone known as, its common name is basically benzoquinone. So if you have phenol like this is your phenol, and you are going to react this with chromic acid like Na2Cr2O7. This is chromic and acid, that means in the presence of H2SO4. Then we will get conjugated diketone. This is your ketone, this is your ketone. And this compound is known as basically benzoquinone. Please do that. After this, I'm going to give some questions because in the last week we didn't have any test. So today we are going to
Done, sir.
Napisa,
Yes, sir.
done.
Yes, sir.
Okay. So now I'm going to give you some question. Please write the question with me. In tomorrow's class, we are going to start ether. Now the question is, predict the major product of acid catalyzed dehydration of the first one is 1-methyl cyclohexanol. And second is butane 1-ol. Question the second. And write the IPC of following. Are you done with the question number 1? First question, have you written it?
Yes, sir.
Four questions are here. Please let me know.
Sir, you are lagging.
Are you done with the question?
Yes, sir.
Okay, please start writing. What about you, Fawaz?
Sir, I am writing.
Okay. Alia, Fawaz, are you done with the question?
Yes, sir.
Okay, please start.
Sir, for question number 2, sir,
Nafisa, are you able to solve the question? Nafisa, Alia, and Fawaz.
yeah. Sir, number 2, like, what is it attached to other than OH? Like the other 2 lines.
This is basically, this means CH3. If nothing is written, that means carbon is there. Okay.
Okay, sir.
Like this. This is CH3 now. This part
Yes,
in the
sir.
same. Okay. Pause. I couldn't get the text you sent in chat box.
Sir, which one? So both.
This is not option.
What?
Question number
Sir, there are
2.
options A, B, C.
No. This you are. It's part of this question number 2. UPSC of this ABCD. Okay.
Sir, what are you saying?
You need to write the UPSC of this ABCD. It's not option. Are you
Yes,
getting
sir.
my
Yes, sir. Yes.
Yes, sir. Finish.
You send PDF to WhatsApp.
Okay, sir. Sir, can you send the PPT for biomolecules, because I have a presentation on Tuesday, I think. For proteins, I have to present. I have to like, the teacher assigned us to do a seminar for biomolecules, and I got the part of proteins. So,
Okay,
so
so
sir,
you
can you
want
send
help in
the PPT
project?
for
Project.
biomolecules?
Okay.
The
It's
notes
project.
for biomolecules. Yeah.
Okay, do you need notes of biomolecules?
Yeah. I want to check if I missed anything. We did that
Okay,
before, right, sir? Yes, sir. Okay.
yeah. Okay, thank you. Forward, what about you? Are you done with this?
Sir, last question is there.
Please do it.
Yes, sir. I sent already. Should I leave now?
Okay, thank you. I'll send it tonight,
Thank you,
okay?
sir.
The notes.
Yes, sir. Okay.
Thank you.
Thank you, sir.